Science at the library. Today we're going to be doing a couple of activities that are going to show the amazing cohesive properties of water. And if you want to follow along at home, you're going to need some pennies, some water, and if you have it, rubbing alcohol and oil. You need a pipette or a straw. And then for the second activity, you'll need a bowl of water and something like a spice. Basil is what I have. You can use pepper. Don't use salt because that'll dissolve in the water. You need something that's going to not dissolve in it. And then you need some dish detergent and either your finger or a toothpick. Okay, so you may have heard people refer to water as H2O, and that is because water molecules are made up of 3 atoms, 2 hydrogens, which are really small, and 1 big oxygen. And the oxygen atom has a lot of electron density around it, and so instead of making a linear molecule, it actually makes a kind of a bent molecule, so it's kind of like a V shape. And because of that, it means that one part of the molecule has a lot of negative charge, and the front side where the hydrogens are has a lot of positive charge. And one of the things that gives you a lot of cohesion in water is that the hydrogens are attracted, because they're positively charged, they're attracted to other molecules, oxygen atoms. So you can get all sorts of hydrogen bonds, which are weak bonds, but there's a lot of them forming, and so you can have all this kind of hydrogen bonding going on between water molecules that are next to each other. And this happens both in the liquid form and also in the ice form, the solid form. So, and the hydrogen bonding, we can kind of see it gives a lot of cohesion to the water in our first experiment, and that is we're going to see how many drops of water we can get onto the top of these pennies. So the first one is water. We're going to just start dripping it on there. Pipettes are easier, but if you have a straw, it should be able to work pretty well too.
I didn't think there'd be anywhere close to that many drops.
Yeah, and I didn't really lose count. When I've done before, you can get about 20.
Holy cow.
So if you look at it from the front or kind of from the side, you can see how it's poofing up there. It's kind of like a little pillow.
That is wild.
Let's see if I can get some more to go. Okay. So that's quite a bit. So it looks like it's standing up, and so where the water meets the air, the water is happier being by itself with its other molecules like it than it is being in the air. So that's why it kind of forms a little rounded shape like that. Wow, that's pretty good.
Yeah, that's
okay,
impressive.
I'm gonna stop. Okay, so let's compare that to what we get with rubbing alcohol. This is on the second penny here. So you can see it's got a little poofiness there. Let's see. Okay, well, so I got it to go up a little bit, but not as much as the water. So
the water's still sitting.
Yeah, and it's kind of bulges out. Oops.
Spoke too soon.
Yeah, I think I jostled it a little bit. See if I can get it back here. Okay, and then oil. So alcohol has some hydrogen bonding, but not nearly as much as water. And then oil is a very nonpolar molecule, so it may have some oxygen in it, but it mostly has carbon and hydrogen, which are not very polar. So let's see if we can get it to, and it's more viscous, but not as polar. So again, it has a little cohesion because the molecules are really big, but not as much as water. So try it at home. See how much, how many pipettefuls of water you can get on there. Another thing you do is take like a drinking glass and fill that with water and then start dropping coins in, and you can get the water to puff up a little bit above the top of the glass. So another possibility there.
That's cool.
Okay, so for our second activity, we're gonna do, we have a big bowl of water, and water has kind of a skin on it because of all that hydrogen bonding, and it's called it gives it surface tension. So you may have seen on a pond in the summer some insects floating on the water. These pond strider or water striders, and they use the surface tension of water to stay up on top of the water. Oops, I didn't do that one very good. So these paper clips are much heavier than water, so you wouldn't think they'd float, but if you can get them right on the surface area, and you can see kind of how it's bending around, how the water's kind of sinking under the weight, but because it's got all those hydrogen bonds, it's holding it up. Oops, missed one. Okay, so there's some of our water striders. And then what we're going to do is add some either pepper or, in my case, basil here. And so this just stays on the top of the surface. And surface tension is holding it up. Well, you can't see surface tension. It's invisible there. So let's see if we can disturb it and make the basil move around here. So I'm going to try adding some water. And you can see it kind of, because of the drop falling, it kind of breaks the surface tension a little bit. Same with alcohol. Try a different spot.
Oh, that's bigger. Oh,
So it kind of.
that's weird.
Yeah, isn't that weird? It kind of makes the surface tension weaker, and then it comes back, and so you can see it kind of moving. That's kind of cool. And then we could try oil too and see what that'll do. And oil is very non-polar, so it doesn't even mix with the water, so it really doesn't do anything. It just sits there in blobs on top. But if we use a substance like dish detergent, which has a very polar end and a non-polar end, it will disturb the surface tension really well. And you can use your finger if you'd rather. But we're going to put this in, and it's going to make the surface tension move. So it moved the paper clips, the basil too. And if you want to do this at home, you can do it as a magic trick. You can have a little soap on one of your fingers, and you can dip your non-soapy finger in the water to show that nothing happens, and then you can say a magic word, put your soapy finger secretly in the water, and then you'll show the surface tension moving away from wherever you put your finger in. So you can do that as a trick for your family. Well, thanks very much for coming to Science at the Library, and next time we're going to be looking at how water and oil interact.